Hello friends, welcome back to Light Tutorials. So today we learn the Matlab code of pulse code modulation. Okay, so here is the thing. Pulse code modulation is one of the important digital pulse modulation technique used for transmitting the analog signals with respect to the message signal as pulse signal. Okay, now this is the general block diagram of pulse code modulation. It has source of the continuous message signal and a low pass signal and a sampler and a message signal and a quantizer and an encoder. Okay, and the receiver part will be the reversal of this PCM system. Okay, now if you see here, this low pass filter is for attenuation. I mean to limit the bandwidth of the signal. Sampler is for sampling. This sampling is of mainly two types: normal sampling, okay, or else flat top sampling. Normal sampling results in sync signals, whereas flat top sampling it undergoes an effect called aperture effect, which is the distortion for the dividing signal. Okay, and quantization. This quantizer it performs the quantization means rounding off to the nearest integer. Okay, as you see here we have two types of laws for quantization: mu law and a law. Here in this example we'll go with the mu law type of quantization. Okay, right. So basically what we are doing is pcm modulation, pcm generation. Okay, here the things we require are: first thing is sampling, next is after sampling what we need quantization, sampling and quantization. Okay, these two are the important blocks. And encoding, we need a general encoder. Okay, so after we perform this, whatever signal we result, that is called the pcm signal. Okay, now I'll show you the code for this. Right, now if you consider this, first thing is here I'm mentioning the time limits. It is from 0 to 3 seconds with a time change of 0.01. Okay, now x is my message signal is a sync signal here. So my message signal is a sync signal. It is 2 pi t. Okay, it is varying with the time. Now next is the compression the signal using mu law. Okay, that means we are compressing the signal, that is called using mu law. Okay, compounding, we use a keyword called compounding. Okay, with signal x as x sync signal, and the highest limit of this is 255. Okay, if you see here it is a 255. This value 255 is for, here is used to represent the ones because it is discrete signal. It is in ones and zeros. Okay, it says the maximum value of the message signal. Okay, and here we used which type of compressor is that we denote here in the brackets called mu compressor. Okay, now this compression using mu law is called the quantizing. Okay, is the one way of quantizing the signal. So we use mu law for quantizing. Next step is encoding. Here we encoded the signal. Okay, it is using u encode. Okay, u encode whatever signal we have got here in C with a sampling rate of what with the encoding 3. Okay, next similarly, that means this 3 includes the number of levels. Okay, the quantization levels are 3. If levels are increased, the original and received signal will be highly correlate. Try for 8 instead of 3. Okay, that means we can even use here in place of 3, that is encoding levels. Okay, what is encoding? Converting one type of signal to the discrete signal or else other type of signals. Okay, for that case we use this encoding signal. Encoding and decoding are for what? they are for security purpose, okay, so that others won't access our code, okay, signals. Using u encode, I have encoded the signal. Using u decode, I have decoded the signal. After that, I'm expanding the receiver signal. Why I'm expanding the receiver signal is compounding them with the mu expander, okay, because the receive signal might be of from values resulting from 1 to 255. So the whatever signal I am getting from the transmitting end, that should be that signal should take all the values from 1 to 255, so that I need to add few values for that, okay. Now I have compounded few values to my original signal, my receiving signal, okay. Then I plotted it with respect to each and every window, okay. Now here, see, this is PCM without compounding, okay. That means I did not compound it with the without I did not compound it here like this. I did not use this thing directly. I've given it, okay. Whereas here I compounded it. Compounding means it's adding the few frequencies, okay, adding few times or near to zero, so that every value is covered in that, okay. Now I'll run this code. I'll save it and run. See, this is the original signal here, okay. Whatever the red mark introduces the original signal here. The black mark is the received signal using compounding. We compounded the signal here, okay. Similarly, if you see without compounding, without compounding, the difference between compounding and without compounding is the received signal, okay. That is of low pulses, but here it is of high pulses. And here we performed normal sampling. That means Nyquist sampling here. That is fs should be greater than or equal to 2 fm, so that we can get our message signal back, okay. If you use flat top sampling or fs less than or 2 fm, then it results in the aliasing effect, okay. So this is how we perform the pulse code modulation technique. That's all for this video. If you like this video, share it and subscribe to my channel. Thank you.